Hi everyone, my name is Klaus Kadelka and I'm also in Dr. Laubenbacher's group. And this work has been done together with Dr. Laubenbacher and also with David Murugar, who was a former PhD student here and is now a postdoc at Georgia Tech in the School of Mathematics. And I want to talk about microRNAs and how they can stabilize gene regulatory networks. Because what is known about gene networks is that they are surprisingly robust to perturbations, and we want to know, like, how does this come? How can they be so robust? And one new player that has been found is these microRNAs. I guess most of you know what they are. They are small RNA molecules that bind to the mRNA, and by binding to the mRNA, they prevent them from being translated, or they also degrade the mRNA directly. And so now what I'm doing is I use the discrete dynamical system framework that has been there for a long time, and I use a stochastic version of it that was developed by David Murugar. And the reason I use a stochastic version is because we know that gene regulation, or the key step of gene regulation, is a highly stochastic process, so we cannot access it from a deterministic point. So what I'm doing is I build a gene network to the best of my knowledge. I know gene networks have a Poisson in-degree distribution, they have a special out-degree distribution, so I build a generative gene network, and then I introduce certain numbers of microRNAs in a special way. And the special way is that I introduce them so that they form feed-forward loops, because that's already has been established by biologists, that they often occur in feed-forward loops. So we have one gene, a transcription factor that regulates target gene, and also microRNA, and then this microRNA inhibits this target gene. So what I did here in this work is I came up with a measure, how can we capture the robustness of the network dynamics, how much stochasticity is involved in a certain network, how much stochasticity is involved in the network where I introduce these microRNAs, and then I compare the robustness of these two networks. And what we see in this plot, that's basically my results for different sizes of gene networks, is that the networks where I introduce the microRNAs, they're always more robust to perturbations than the original gene network. And so I came up with a way to quantify the robustness of a gene network, and I also showed that these microRNAs are indeed a key regulator or a key player in making gene networks more robust. And if you want to know more, come to my poster. I'll be happy to talk to you. Thanks.